Figure 130. A uniform beam HK of length 10 meter and weighing 200 Newton is supported at both ends. A man weighing 1000 Newton stands at a point P on the beam. If the reaction at H and K were respectively 800 Newton and 400 Newton, calculate the distance HP. Solution. Figure 131 shows a uniform beam of 10 meters HK weighing 200 Newton at a point O. If the vacuum reactions are respectively 800 at H and 400 at K, and the man having 1000 Newton weight at P, we are asked to get the distance from H to P, which is x. Then, taking moment about H, clockwise moment is equal to anticlockwise moment. Since the reaction is acting upwards, therefore 4 times 10, which is the length, 400 Newton of the reaction at K, times 10, that is the distance, the length of the meter rule, is equals to, since the weight of the meter rule is 200 and the half of it is now 5 meters, therefore 200 times 5 plus 1000, which is the position where the man is, times x, which is what we are looking for. 100x, collecting like terms together, making, we have that 100s is equals to 4000 minus 1000. Then making x the subject of the formula, we have 3000 over 1000, which will give us 3 meters. Example 4. A non-uniform rod XY of mass 40 kg and length 5.0 meters lies on horizontal ground. Its center of gravity is 2.0 meters from the end X. Calculate the vertical force P that will be sufficient to lift the end Y from the ground. Why would the force P, if applied at the end X, not be sufficient to lift the end X from the ground? Take G equals to minus 10 meters per second. Solution. Figure 132 shows a non-uniform rod XY of length 5 meters and weight 40 kg times the acceleration due to gravity, which is 10, which will give us the weight as 400 Newton. And the center of gravity of the non-uniform rod is 2 meters from X. Then we are asked to get the force required to pull the rod, non-uniform rod, at a point P upwards. Taking moment about X, clockwise moment is equal to anti-clockwise moment. Since the P we are looking for is covering a distance of 5 meters from, as we are taking the moment as S, then which will now be equal to 400 Newton, the weight of the non-uniform rod, times 2, which is the distance from the center of gravity, or the weight of the non-uniform rod. We now have our P, making P the subject of the formula. We have that 400 times 2 all over 5, P will now be equal to 160 Newton. Suppose force P1 is applied at X. Taking moment about Y, we have that P1 times 5 is equals to 400 times 3. P1 is making P1 the subject of the formula. We have that 400 times 3 all over 5 is equals to 240 Newton. 240 Newton is greater than 160 Newton, or P1 is greater than P. P would be sufficient to raise the rod at X. Example 5. A meter rule having 20 Newton, 1.5 meter from the fulcrum and on the left, and 10 Newton, 1.5 meters from the fulcrum on the right. To determine the moment on each side, moment is equal to weight times distance, which is 20 times 1.5, which will give us 30 Newton meter. Moment on the other side, which is on the anti-clockwise side, which is 10 Newton times 2.5, which is the distance from the fulcrum, will give us 25 Newton. A meter rule is being pulled by a force of 10 Newton at an angle of 30 degrees to the meter rule, and the meter rule is 2.5 meters from the fulcrum. Therefore, the horizontal component of the force is 10 cos that, while the vertical component of the force is 10 sin that. Since we want to get the actual distance or resultant force Y, we now see that by resolving the force, we have our length to be 2.5 and the angle to be 30 and our Y unknown. Then sin theta or sin 30 is equal to Y over 2.5. Therefore, our Y, making our Y the subject of the formula, we have 2.5 sin 30 equal to 1.25 meters. The force, to get the force, we take the horizontal component, which is 10 sin 30. Force will now give us 5 Newton. Then the moment is now equal to 5 times 2.5, which will give us 12.5 Newton meter, or sin 30, which is equal to Y sin 2.5. 2.5 taking like terms together, we have that 2.5 sin 30 is equal to Y. Therefore, our Y is now equal to 1.25. Therefore, the moment is now equal to 1.25 times that of force, which is 10, which is still give us 12.5 Newton. Stability. For a uniform body, the center of gravity acts at the middle. For non-uniform body, the center of gravity acts at the heavier part at the axis or end. Stability. Any object, its center of gravity can be decreased or increased. That object is stable. A cube on a ground is stable. A triangle on its tip is unstable, while a rolling cylinder is neutral. Neutral thrusts linear motion and therefore moves. Example 7. A uniform beam of mass 10 kg is pivoted as shown in the diagram below with weight attached. AB equal to BD equal to 1.5 meter. BC equal to 1.2 meter. Can the